I think consciousness was there before life started, and is probably why life started. I thought, well, maybe Roger's objective reduction was there in the primordial soup. It would have been everywhere, and these simple molecular complexes could have accessed it and had moments of consciousness or proto-conscious experience. A rock as a whole is not conscious, but the atoms within it could be having proto-conscious moments, but they're not talking to each other. So the rock as a whole is conscious, but within it are all these proto-conscious entities, noise, not only in the rock and everything. To use a metaphor, if you go to the symphony and musicians are tuning their instruments and they're tuning it to A and they have a method, but to me, a non-musical person really, although I love music, it sounds like a cacophony. It sounds like noise. So that's like proto-conscious noise. And then the orchestra starts and you get a symphony. And so I think what the brain does, and specifically what microtubules do, is to orchestrate the proto-conscious noise, like the instruments being tuned up, into Brahms or Beethoven or the Beatles or whatever.
Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0.
Dr. Hameroff, welcome to the Ignition Sequence podcast. Thanks for coming on with us.
Thanks for having me, John. Nice to be here.
So, wow, you got a background in anesthesiology. That was your course of study when you began your career. And tell us about how you kind of got into this world of considering consciousness. And by the way, I've had a couple of surgeries and I love going under. That is fantastic, man. What a ride that is.
Well, yeah, we induce with propofol, which is a great drug. It got a bad rap from Michael Jackson, who used about 1,000,000 times too much. But it's a wonderful drug. It burns a little on injection, but it's euphoric. It takes away pain, and patients wake up feeling happy, smiling, and
Yep.
mood elevated. So yeah, it's a great drug, propofol. And then we usually use gas for maintenance. But I was actually interested in consciousness before. In fact, I chose anesthesia because of my interest in consciousness. I'd gotten interested in it in undergraduate in the late '60s, and took a philosophy of mind class. I was a pre-med, but took philosophy of mind and liked it very much. And it was the late '60s, and we did stuff back then that people did in the late '60s that they're doing again. And I got interested in consciousness, and so I went to medical school and was oriented towards neurology, neurosurgery, psychiatry, something to do with the brain mind, but those lifestyles didn't appeal to me too much. And so I moved to Arizona and got a rotating internship and stumbled into anesthesia, and the chair of the brand new anesthesia department, the brand new medical school here in Tucson. I met him and he said, well, if you want to figure out consciousness, figure out how anesthesia works, because we use it every day and we don't have a clue what it does, except that it's fairly selective for consciousness. It takes away consciousness while the brain remains quite active. So it's a great way to understand consciousness, and that was the best advice I ever got career-wise. And he said, and I had gotten interested in these structures called microtubules in medical school, which are structures inside neurons. I was studying, doing research in a cancer lab, cancer research, and cell division, mitosis. So the chromosomes are pulled apart into two precisely equal sets, cell division. And if that goes awry, if there's too many here, not enough here, or it's not perfectly divided, you can get cancer or maldevelopment or something like that. So the precise separation of the chromosomes were key, and this was accomplished by mitotic spindles, structures that pulled the chromosomes apart, and they turned out to be microtubules, which were a new concept to me. And in fact, their structure had just been discovered as a kind of a lattice, a cylindrical lattice. And I was learning about computers at the time, and the lattice looked like a computer matrix to me. So I got the idea that they were processing information and might be computers, and they were discovered to be inside neurons. So I said, well, maybe they're underlying consciousness. And so I set up, when I got into anesthesia and joined the faculty, after my residency, I started studying microtubules and looking at anesthetic effects, but mostly actually they're kind of hard to study at that level. Mostly I did computer modeling and simulation of microtubules processing information like computers, and work with physicists and uh, uh, including Steen Rasmussen, Jack Tuszynski, and others, modeling microtubules as automata. So they're kind of like a hollow ear of corn where each kernel is a protein called tubulin that can be in at least two different states and interact with its neighbor states. And they were vibrating and oscillating. And we modeled patterns and information moving. And this would increase the information capacity inside the neuron tremendously. So AI, you mentioned AI, and neural net people were saying that a neuron firing is like a bit. So you put enough neurons together, you have enough bits and enough complexity, consciousness happens, which was a conjecture because that's how they assume the brain work at the level of neurons, period. And I didn't think that was right because if you look at a single cell like a paramecium, so a neuron would be like a bit, a one or a zero. A paramecium is
Mm.
also a cell, and it would be according to that logic, would be a one or a zero. But paramecium can swim around, find food, find a mate, have sex, learn, do all these things. And another single cell organism, the amoeba,
Mhm.
slime mold amoeba, which had been studied for 150 years, going back to Claude Bernard, showing that amoeba movement was inhibited by anesthesia, can solve the traveling salesman problem. Some very clever experiments by a number of people, including Adam Adamatsky, had shown that slime molds can actually, by extending pseudopods and by going for food or aversive or away from aversive therapy, could solve something like the traveling salesman problem, which is fairly difficult. And both the paramecium and the slime mold do their cognitive functions with their microtubules as processing information. That's not to say that they're conscious, although they could be, but at least they were cognitive, and they were much, much more than a one or a zero. And they seem to be processing information with their microtubules. So I thought it had something to do with consciousness inside brain neurons. So that's how I got into this. And so I was going around AI and neural net meetings and being kind of a pain in their butt, actually, because it's my specialty. The
Yeah.
singularity folks, Kurzweil and others. Actually, this started with a guy named Hans Moravec at Carnegie Mellon. He wrote a book in 1986 called Mind Children, about the first description I'd heard of downloading your mind into a computer. It was just fanciful or conjecture. Um, and the way they figured the brain capacity for information, which Kurzweil latched onto, was about 100 billion neurons in the brain, in human brain, which is roughly true. Switch with about 1,000 synapses, switching at about 100 hertz, gives 10 to the 16th operations per second. So, according to
Wow.
the idea that the brain is a complex computer of simple neurons, you get they were saying if we get to 10 to the 16th operations per second, we'll have brain equivalents in a computer, and therefore we'll be conscious because that's all the brain is. And I was going around saying, no, 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 each neuron is not just a one or a zero. It itself has about a billion tubulins, the subunits of microtubules, switching at about 10 megahertz, which gives 10 to the 16th operations per second per neuron. And then you'd have to multiply that times 10 to the 11th. So it's more like 10 to the 27th operations per second. So I was going around saying, no, no, you guys have your goalpost is way, way further down, more like 10 to the 27th for information processing capacity. And they didn't like that, because they wanted their sponsors to believe that they were close to brain equivalence and consciousness.
Mm.
And so they kind of told me to get lost mostly. And but I had other outlets, anesthesia conference and so forth. But one day somebody said, and this was a real turning point in my life. Somebody said, "Okay, wise guy, let's say you're right. How would that explain consciousness? How would more information processing explain the feelings, love, joy, emotion, the color pink, everything that later came to be known as the heart problem, coined by David Chalmers, but had been talked about by other people earlier, John Searle and Nagel and many others. And actually,
You're talking about the emotions of the heart problem, the emotions of the heart.
emotions, feelings, conscious
Yeah.
experience,
Right.
awareness.
Got it.
People ask, well, first define consciousness. It's pretty hard to define, actually. But life is also hard to define. We can't really define
Yeah.
what life is. And, there was once, this is an apocryphal story. There was once a conference that decided the first day they were going to define consciousness and then go on to explain it. And by the end of the week, they were still arguing about a definition. There are a lot of words: awareness, feelings, phenomenal, subjective, first person point of view, this and that. They're all words, and they're all pretty accurate, but they don't explain what it is. From a scientific perspective, the best definition is what goes away with anesthesia and comes back when the patient wakes up. And I kind of borrowed that from Searle, who defined consciousness as what goes away when you fall asleep into a dreamless sleep and comes back when you wake up. And sleep is different. So I adapt that to anesthesia. And what goes away with anesthesia and comes back, since anesthesia is selective and only affects consciousness primarily. So anyway, I had to admit I was stumped. I didn't have a mechanism. It was just more computation. And it was a little depressing, actually, because I thought I was being different, but yeah, I still ran into the hard problem, which hadn't even been invented yet. But fortunately, the same person, and I wish I could remember who he was, because I owe him a debt of gratitude, suggested I read a book by Roger Penrose called The Emperor's New Mind, which I did, because Roger in that book took exception to the idea that consciousness was computation. And he argued from something called Gödel's theorem, which was a mathematical theorem by Kurt Gödel, which said that a mathematical theorem cannot prove itself. The theorem can't prove that it's true or false.
Hmm.
It needed something or someone outside the theorem, like a mathematician, a conscious individual.
So like the Pythagorean theorem, which is a squared plus b squared equals c squared, something like that, has to be proved outside of its own, formula, and by somebody putting the numbers in and saying, "Oh, well, yeah, that comes out correct. That's an actual correct calculation."
Right. It involved, yeah, and Roger extended that to understanding. He said, understand, and the way I'm taking a shortcut here, but I think it's a good one. Understanding is a feeling. When something you feel that this is right, intuitive feeling, or just knowledge in general. You feel it. Okay, that's right. I understand that. So understanding is kind of a feeling, and that was the main point. There was something other than pure computation. Because if the brain's a computer and consciousness is an output, who's viewing the output? Who's the audience? And so computation per se doesn't do it. So I'm very skeptical and dubious about AI being conscious now or in the future based on classical computing. There are ways to get around it, but I don't. But as great as these LLMs are and as impressive as they are, I don't think they're conscious, and I don't think they'll ever be conscious, as bright as they may be, because they're lacking the specific non-computable mechanism, which involves quantum physics, unfortunately for most people, since they don't want to deal with it.
Yeah, I was going to ask you about the quantum mechanics. Isn't that what kind of Roger Penrose, who was a British
Yeah.
physicist, brought to it? You know,
Yes,
melding quantum physics into it, quantum mechanics into it.
right. The first part of the book, The Emperor's New Mind, was about Gödel's theorem, arguing against computation as the answer to consciousness. And by the way, the emperor, I think, was, like the old parable about the emperor has no clothes. And so it was a clever title. And I think the emperor in this case was AI, or more specifically, Marvin Minsky, who was the main AI guy back then. But you could have replaced it later with Kurzweil or anybody, or just AI in general. So the first part of the book kind of debunked the idea that consciousness was purely a computation, that something else was needed. The second half of the book put forth an idea of what that was needed. And for something outside the system, he implied that to mean outside classical physics, outside the classical
Hmm.
world, and into quantum physics. And at that time, I had only a vague understanding of quantum mechanics at best. And still, I've studied it as best
Yeah.
I can, but it's paradoxical. It's very difficult to understand. And I think it was Feynman who said anyone who claims to understand quantum physics is either lying or crazy, because it's so counterintuitive and bizarre. And so, in a nutshell, basically, the world is divided into two realms. Um, our classical world that we're used to, that we deal with, where things are fairly large, particles are in definite places at any one time, and follow predictable laws of science, Newton's laws and Maxwell's equations, this and that. And everything was kind of copacetic up until the late 19th century when quantum mechanics was discovered, and they found out that at least at small levels, small particles, whole different set of laws applied, the laws of quantum mechanics. So, for example, a particle, which in classical physics is here or here, could be both here and here at the same time in quantum superposition. Actually, here, I'm going here, kind of like a wave. So a particle could be a wave, but yet when you measured it, a machine measured it, or if a person looked at it, observed it, the multiple possibilities collapsed or reduced to one. So the superposition of multiple possibilities described by the wave function, the quantum wave function, collapsed to one particular state. And this was actually put forth by the pioneers of quantum mechanics, von Neumann, Wigner, and Bohr kind of went along with it because conscious observation or measurement allowed them to continue to do quantum physics and develop, you know, electronics, technology, all the great stuff we have today, without really understanding what was going on at the quantum level. But Roger wanted to know what was actually going on, as did Einstein. Einstein didn't like all this. He didn't like initially some of the things about quantum mechanics. And he wanted to understand the underlying reality of how things can be in multiple places at the same time. And but the guys doing quantum physics they didn't really. Some of them, like Bohr, didn't really care. They just wanted to, as he was famously quoted as saying, "Shut up and calculate. Just forget about what's really going on and just do the math and let's use this stuff." And they did. So that led to electronics and all the wonderful things. Uh, but how can something actually be in multiple possible states? And I'll come back to that in a second. But the other things in quantum physics are non-locality. So if you have a particle over here that's in superposition and use two particles, let's say, that are together, and you separate them, if you make a measurement over here, this one instantaneously feels it despite being separated. So instantaneously means that any signal travels faster than the speed of light, which Einstein didn't like, and he called it spooky action at a distance. So he didn't believe
And when
it.
you're talking about particles, are you talking about, atoms, neutrons, subatomic or, kind of what particles, when you say particles, what does that mean?
Well, that's a good question because it's somewhat arbitrary. Certainly, atomic and subatomic particles, but even larger things can be certainly entangled or can be in superposition. So the cutoff between the quantum and the classical world can vary. It's a boundary that can change, and that's the mystery. And we're still working on that problem. And if you get in the classical world, things are too big and too warm, they say, for quantum effects. But entanglement works even at a warm temperature, and it's still a mystery how things can be connected over distance and without faster than light. And although Roger's explanation is if you make a measurement here, the information goes backward in time to when the two are together and back and out to the other one. So that's still being worked on. So superposition, entanglement, coherent condensation, where multiple quantum particles can collapse. Sorry, not collapse, condense into a unitary object. So Bose-Einstein condensation, for example, you can prepare a set of atoms that are perfectly coherent, kind of like a laser, and they become one entity. And this would be very useful in consciousness for the sense of self, binding of spatiotemporal information into a unitary quantum thought. So those are the three main mysteries, I think: superposition and the measurement problem. Why, when you make a measurement, you see one definite particle instead of a wave. Entanglement, how things can be connected over space and time, and condensation, how things can unify into into unitary quantum objects. So those are still somewhat mysterious. Roger Penrose is, as far as I know, the only one who attempted, who has explain the logically a mechanism for superposition of multiple possibilities. And to do that, he made an amazing leap by bringing in general relativity, Einstein's general relativity. And in that, Einstein came up with this idea of the space-time continuum, the space-time metric, that much smaller than atoms, particles, if you go down and down in scale, there's some irregularity, there's some information, there's some coarseness in the universe, and that turns out to probably happen at the Planck scale, the very kind of the basement level of the universe, very small and very fast, 10 to the minus 33 centimeters. But he said that that mass, any matter, would be equivalent to a curvature in space-time geometry. And so he predicted that, for example, the light from a star behind the sun. Okay, here's the sun, and here's a star,
Mhm.
and the light would curve around the sun, and therefore, if we were down here on Earth, we could see a star that was actually behind the sun. And he predicted that, and in 1919, Arthur Eddington
Wow.
did the experiment and proved it, and during
Hmm.
an eclipse, so he wasn't blinded by the sun. And he went to a mountaintop on an island off of Africa, I think, and set up his telescope and waited. And sure enough, when the eclipse happened, he could see just to the side of the sun these stars, which were known to be behind the sun because the light from them was curved by the mass of the sun, by this curvature in space-time geometry. And so that proved
Jeez.
Einstein's theory, and Eddington got his own Nobel Prize. And there's this wonderful picture of the two of them celebrating on a bench somewhere. And so space curvature of space, so that connected general relativity and quantum mechanics, which has been a real well, I'm getting ahead of myself. Uh,
Well, I know we can go down so many rabbit holes with this topic, but I want to kind of get back to you working with Roger Penrose, connecting, coming up with the Penrose Hameroff method, which by the way, I found this quote online. ChatGPT was asked how it could become self-aware. How could ChatGPT itself acquire consciousness? And the answer from ChatGPT was, I would use the Penrose Hameroff method.
yeah, I know
So
that.
congratulations to you. What? Tell me about that.
Well, that was done by a guy named Brian Remley that I interact with on Twitter, and which is where I do most of my arguing, by the way, or X, whatever it's called now.
X now, X, yeah.
Sorry. Uh, anyway, let me go back to one point because it's kind of so Roger took this curvature idea and applied it to tiny things. So a particle, an atom, or an electron would have a tiny curvature. So a particle here and a particle here would be opposing curvatures. So it was actually a separation in the fine scale structure of the universe. And other interpretations of quantum mechanics include the many worlds that each possibility branches off and forms its own universe. And this could lead to that. If these separations continue, you'd have their own each would have its own universe. And Roger said that no, the separations are unstable, and after a time t will collapse to one or the other, reduce to one or the other. And when that happens, that would produce a moment of conscious experience. So this was the opposite of the idea that consciousness caused collapse, which Wigner and von Neumann and other people, including Chalmers and Kelvin McQueen and others recently, Henry Stapp, have always said that consciousness causes collapse. But that doesn't explain consciousness, nor how it affects the collapse, or how you have a superposition in the first place. So Roger turned that around and said, it's not that consciousness causes collapse. Collapse occurs spontaneously and causes consciousness. And he used these very clever, simple diagrams in the book. And that point I got. I'm going back, 30 years when I read that book, and it is pretty mind blowing. And but he used these very clever drawings and cartoons to make it understandable. So I got that. So the collapse occurs, the separation of space time. It'll collapse at a particular time t, given by a very simple equation, to one or the other, and that gave a moment of consciousness. And that was and remains, I believe, the only scientific proposal for conscious awareness, for conscious experience, other than emergence, kind of hand waving. You get complicated enough and consciousness happens to it, for which there's no proof or no mechanism for. So I got that out of it, and I thought, wow, this is really cool. But he didn't have he needed a quantum device in the brain that could implement this, and neurons are too big. And so at that point, early 90s, I had been studying microtubules for 20 years
Mhm.
and knew that they had something at the quantum level. And I said, wow, he needs microtubules. He doesn't know about them. So I wrote him a letter, an old-fashioned postal letter, and mentioned that I was going to be in England. I'd be happy to come visit him and discuss this with him. And I sent him a book, some papers, and about a book I'd written about microtubules. And he wrote back in a regular old. This is before I think email was just coming into play, and back then. And so I got a letter back, and he said, "Sure, please come on, the day we had arranged, and come to Oxford." And so I did. I took the train, and he met me at the train station, and we went to his office in the Mathematical Institute. And he said, "So, tell me about these microtubules. Are they real or are they simulations?" He was a bit suspicious about them. I said, "No, no, no. They're biological. They're in every cell." And I showed him the book I'd written, all these pictures of microtubules and papers and stuff I had done, and I did most of the talking. As you can tell, I like to talk about this.
Yeah, yeah.
So we spoke for about 4 hours, as I remember. And at the start, he mentioned he was going to a meeting at Cambridge on consciousness with two very well-known philosophers, Dan Dennett and Pat Churchland. And I said, "Wow, that sounds interesting. I'd like to go, but I got to go to this other meeting, which is why I'm here." So he said, "Well, thank you very much. That was interesting." And he shook my hand. He's very gracious,
Right. He's a
wonderful.
very proper Englishman. He's a very proper Englishman. Yeah, yeah.
Yes, very polite, very somewhat reserved. Although he can get agitated and when indicated. But so we shook hands, and I walked away. I said, "Wow, that was cool. I got to meet Roger Penrose. That was great." And I didn't think anything would necessarily come of it. But 2 weeks later, I was flying back from London, and my friend said, "Hey, I went to this meeting in Cambridge, and Roger Penrose was talking about you and your microtubules and consciousness." And I was like, "Wow, that's pretty cool." And soon after that, I got invited to a meeting in Sweden that he was involved with. And so we met, and we started applying his idea of objective reduction, a collapse of the wave function due to an objective threshold, to microtubules, which turned out to be pretty tricky because we needed quantum effects in biology, and everybody said, "Well, the brain is too warm, wet, and noisy for quantum effects." But eventually,
And why is that? Let me just real quickly. Why is the brain too warm, wet, and noisy for quantum effects? Do quantum effects normally have to take place in absolute zero conditions?
well, that's what everybody was saying. Because if you want to build a quantum computer in the laboratory, the enemy is thermal vibration. Because, like in an ion trap, we have an ion in superposition of two places, and any vibration is going to knock it out of superposition. It's going to collapse due to what's called decoherence, thermal decoherence. So to get around that problem, they do it at near absolute zero. And
Right.
so that was the standard explanation. Well, ignoring the fact there's quantum effects all over the place all the time, but they seem to be random and so forth. But we thought at that time, well, and I had some evidence from Froelich coherence. This guy, Herbert Froelich, had proposed a kind of quantum coherence in biology. And I knew that anesthesia acted strictly by quantum effects. So I figured, well, consciousness must be a quantum effect. And so and we also figured, well, biology has had a couple billion years to figure this out. So we certainly can't exclude it. And but no, we were attacked, we were ridiculed, we were made fun of. Everybody, these guys.
And you still are today, aren't you?
Yeah, but I think we're gaining ground, and even though we're outnumbered, and AI has come along to push the AI narrative, and is probably funding labs that support their idea. So I call them cartoon neuron theories, because the idea is that a neuron is a one or a zero and only uses its membrane and is algorithmic and ignoring everything that goes on, and only operates at one fairly slow frequency range, like an EEG from 0 to 100 or maybe a couple hundred hertz at most. It turns out that if you go inside the neuron to the microtubules, there are not just hertz, but kilohertz, megahertz, gigahertz, and terahertz oscillations. So faster, 1,000 times each time down into the
Hmm.
quantum realm. But we didn't know that at the time. That was discovered by a guy named Anirban Bandyopadhyay, an Indian scientist working in Japan at the National Institute of Material Sciences. But we didn't meet him until about 2010. So back in the mid 90s or the late 90s, we were getting a lot of heat from people who just said this is ridiculous. The brain's too warm, wet, and noisy. But then in 2006, they began to discover quantum effects in photosynthesis in plants. So
Mm.
plants in the sunlight, warm sunlight, used quantum effects to take the photons they absorb and convert them to chemical energy, which is, and we eat the plants, and animals
Yeah.
eat the plants, and we eat the animals. So life wouldn't be here without that. So, so that was a step in the right direction. And then Anirban came along, and he started studying microtubules, which we were proposing were the quantum devices, and found these coherent oscillations in kilohertz, megahertz, gigahertz, and terahertz, and it somewhere along that line, and it can you get into the quantum realm. So this was showing that there were quantum effects going on in microtubules. And what we've been trying to do since is show that the quantum effects go away with anesthesia. And we've had some success with that. And so I claim, there are so the other theories are based on the brain is a complex computer of simple neurons, like a one or a zero, based on what I call cartoon neurons. And the neuroscientists don't like it when I say that, but they've been making fun of us for all these years. I figured it's fair play because they're and actually, I got that from Christoph Koch, probably the world's most famous neuroscientist, who spoke at our first consciousness conference in 1994 and showed a picture of a neuron that was completely empty. And I said, "Well, Christoph, how do you know consciousness isn't coming from inside the neuron?" And Christoph's a character. I don't know if you know him or have seen him, but he said, "I'm going to answer Stu. I'm going to answer you in my as my favorite cowboy western movie actor Clint Eastwood, who said a man's got to know his limitations." And I think that was from Magnum Force or something like that. And it was a good answer because I wasn't expecting that. It shut me up. I didn't have a rejoinder. So and he got that from Francis Crick, who discovered this structure of DNA and then went into neuroscience. And for some reason, after this wonderful detail in DNA, he kind of retreated into the whole neuron's a one or a zero. The brain's a pack of neurons, and that's what Christoph joined him, and that was their idea. So they kind of started the cartoon neuron idea, and all the other theories of consciousness are based on what I call cartoon neurons. They wouldn't like the term, but anyway, that's what I call them. So. Uh, the point is that in the last 5 years, I claim, and I'll stand by this, that there's more evidence, experimental evidence, for quantum effects in microtubules as the origin of consciousness than there is for all the other theories, because we've shown effects of anesthesia taking away these quantum effects proportional to the potency of the anesthesia. So
All right.
anesthesia.
I just want to interrupt here for 1 second here to kind of go back. Biologically, when anesthesia is given to the human body, physically, what happens inside the brain to these neurons, these microtubules? What is taking place physically that, takes away this consciousness that we understand as a human being?
Well, that's a very good question, and I can tell you what we think based on our evidence and theory, and we're trying to prove it, and we have some evidence. First of all, anesthesia, the anesthetic gases, and propofol is a special case because it's not a gas, but it's very similar. So the gases are inert; they don't form chemical bonds. For
Mm.
example, the element xenon, it's one atom and has a completed outer shell. So there's no electrons available for charges to make chemical bonds. It doesn't make any chemical bonds. It's inert. But what it does is it forms quantum interactions. So if you have a xenon atom, with another xenon atom or two of these nonpolar uh, anesthetic molecules, or any nonpolar biological molecule like aromatic rings, like benzene, organic chemistry, which is the basis for life, organic chemistry, which comes from benzene, which also goes in our gas tanks. It's a I'm digressing a little bit here, but bear with me. So, um, in chemistry, hydrocarbon chemistry, uh, hydrocarbons are like can be chains of alkanes or alkenes of carbon and hydrogen, but they had a molecule C6H6 which didn't fit, and Kekulé had a dream. A German chemist had a dream that the alkanes, which were linear, were like snakes, and one snake swallowed its tail to make a ring. And actually, this became a mythical, or was a mythical thing called the Ouroboros. And he
Mhm.
woke up and he said, "Aha, benzene is a ring, 6 carbon ring." And sure enough, he was right. And the reason that that's important is that there are 3 extra electrons in a carbon ring that don't have anything to bind to, so they form these clouds, electron clouds above and below the ring. So a benzene ring by itself is kind of a quantum object. It's got these electron clouds that are superposition. The electrons aren't in any one place; they're kind of spread out all over the place and in superposition. And so so aromatic rings are like that. Anesthetics are like that. And when that happens, if you have two of these electron clouds, they even though they're inert, they attract each other because the electrons in this one repel the electrons in this one, and you form a dipole. So the electrons are off to one side and the positive charge on the other side. So you have essentially two bar magnets, and they attract. And once they get to a certain critical separation, they oscillate back and forth. And they
Right.
oscillate in terahertz, which is in the optical region. And and that happens in terahertz, and in larger structures like microtubules, which have these rings inside of them in the aromatic amino acids, you get when you have more mass, you get slower and slower. So that seems to be the origin of the terahertz, gigahertz, megahertz, kilohertz in microtubules, and we predicted that anesthesia would block these quantum terahertz and gigahertz and megahertz oscillations. And so we've done experiments looking at anesthetic effects on the quantum effects in microtubules, these oscillations, and shown that they're inhibited or dampened by anesthesia. And that's the way we're trying to prove these, and we're also trying to look at it in other ways where we can actually measure megahertz from the scalp now. In there's all these things buried in the EEG, which are much faster, presumably coming from microtubules. So, the point is that after all this ridicule and still being ridiculed by people who don't know any better, we have more evidence than all the cartoon neuron theories combined. And when I say that, people get pissed off, and I said, "Well, give me an example," and they can't. We're outnumbered, but uh, truth is not an election. Just because you get outvoted doesn't mean you're wrong.
I guess I guess what I'm trying to wrap my head around is if the application of anesthesia to a biological region causes these stopping, freezing, this oscillation and stuff, it's all a biological interruption, is what you're doing with the anesthesia. It's a biological interruption that takes away my consciousness. Um, how can that be transferred to a non-biological thing like, a computer program or AI, and then call it consciousness?
It
How
can't.
can that even be
It can't.
possible?
Well, it could be if you build a quantum computer based on these organic interactions, which is what my friend Anirban is doing actually in a big project in India, uh, funded by the Indian government. They're building a self-organizing, warm temperature organic quantum computer. And if you have a quantum computer that it doesn't need extreme cold, you're way ahead of the game right there. If it'll self-organize itself, that makes it even better. And something like that at some point could be conscious. So there could be quantum AI consciousness, and a number of people are working in that direction, including Anirban, and there's a company in Vancouver. What's it called?
Jeez.
Uh, nirvanic technologies by some physicist Suzanne Gildert I was just reading about. So people are I think Microsoft and others are working towards organic quantum computing. They conceivably could be conscious, or it could happen in something like fullerenes, carbon nanotubes and buckyballs and things like that, which have organic structures. But building, classical computers out of silicon, I don't think can ever be conscious. So LLMs, as
Right.
wonderful as they are, I don't think will ever be conscious.
Well, if you take the Penrose Hameroff method and say your theory is absolutely correct, it has validity to it and could be fully proven. What does that mean for understanding free will, creativity, nature, reality? Does that come into play with everything?
Well, I think so. Yeah. I mean, you mentioned several things there. So let's take free will, which is a big problem in philosophy and everything else. There's the overarching problem of determinism that everything is already determined, and whatever we do, we were destined to do it. You did that because
Yeah.
everything lined up in that way, and that takes. But that's kind of how do you get around that? Well, if you go back to Roger's original idea that consciousness is not a computation, that means it's not algorithmic. And
Right.
everything I just said would depend on an algorithm and follow according to the algorithm, and things would be predetermined and destined, and free will is impossible. But there's the little loophole there is the non-computability. That is to say, when the reduction occurs, when the space-time separations go here or go there, and maybe if you go this way, you decide to have pizza for lunch. If you go this way, you decide to have a turkey sandwich for lunch or something like that because I just feel like a turkey sandwich, and
Mm-hmm.
something like that. And obviously, that's a kind of a trite example, but this could apply to anything. And and our and that could be that's attributed to which you choose is attributed, in Roger's view, to what he calls influence by Platonic values. So,
Yep.
the possibilities for, how something is chosen is either algorithmic or random, and that's what everybody assumed. Well, if it's not algorithmic, it has to be random, which is what most quantum effects are ascribed to be. But in Roger's view, in consciousness at least, the collapse is influenced by Platonic values, which are somehow embedded in the fine scale structure of the universe. And when I read that, I thought, well, that sounds kind of spiritual. This could be divine guidance, the way of the Tao, that
Right.
sort of thing.
I was going to ask you about, what about just, the soul aspect of it? If, is the soul the generator of consciousness? I don't know. And does our soul go away when we get anesthesia? Does my soul leave my body when I'm under the influence of anesthesia? I don't know. Great complex question.
We hate when that happens under anesthesia.
Yeah.
Actually, because that's conflating, the near-death experience and out-of-body experience and that sort of thing. But if consciousness is happening in space-time, as I said, normally the space-time here between your ears, uh, um, well, let me go back. So about 2000, they started studying these patients who had cardiac arrest. Pim van Lommel in Netherlands and Peter Fennick in London. They studied people who had cardiac arrest and interviewed them, and they found that both found about 17% of them reported that the near death and out of body experience, the white light, the tunnel, sense of calm and serenity, visiting, seeing dead relatives, and that sort of thing. And then they were resuscitated. They came back and said, "Wow, I had this experience," and everybody had more or less the same story. And if you look in the literature, you see the same stories going back, every culture all around the world going back thousands of
Mhm.
years. So I thought, this has to be real. And so anyway, the BBC, Peter Fenwick was in London. I wanted to do a show about this. It was brand new at the time. And they asked, so BBC asked Peter and Pim van Lommel, how to explain this. And they said, we have no idea. Why don't you ask Penrose and Hameroff because they have this crazy idea about consciousness. And Roger avoids anything to do with spirituality. And because I asked him about, and he said, I just don't like. He said basically I have enough problems, because my theories are already pretty radical. So he just doesn't. He didn't want to go there, but
Right.
ignorance is bliss. So I waded into it and not knowing any better and figuring I have nothing to lose. I'm an anesthesiologist. What do people care? What am I going to?
Right.
So I said, and I was on the BBC show about this. It was called "The Day I Died," about one particular experience. And I said, well, it could be that when the blood stops flowing and the oxygen drops, that the quantum information in space time that's normally adhered to the microtubules would dissipate to the universe at large, but remain entangled, so that all the quantum information of you or the person, your memories, everything else, your soul, if you want, would be distributed in the universe but remain entangled as a unit. So, afterlife and even reincarnation are possible, and astral projection, all
Hmm.
things that
Wow.
we read about, which scientists say, no, that's impossible, forget it. Well, until you can explain consciousness in the brain, you can't exclude consciousness out of the brain. And because if it's a quantum effect in space-time, sure, why not? I mean, the universe itself is probably holographic and quantum at a basic level, so we don't really know. And if you go back to um, the hierarchical levels in the brain, in the microtubules acting collectively, so they're all kind of communicating by entanglement. You go faster and faster, faster, and eventually, and smaller, 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 and you get smaller than the atoms, and so you're in space-time geometry, so it becomes non-local, and so consciousness can be non-local, even without dying, even while you're still conscious, or in some altered state, and you know. Astral project. I remember reading a book about astral projection by Tibetan monks. I said, that's interesting. How could that, and remote viewing, all the stuff that we hear about that people just discredit or don't pay attention to because it doesn't fit with their view of classical physics and reality. But if the consciousness is quantum, then they could be true, and they probably are true, actually.
Yeah. So you and Penrose came up with this orchestrated objective reduction, orc OR. Is that how it's?
Orch OR, yeah, yeah.
Yeah, orc OR in the scientific community, orchestrated objective reduction. Um, can you just tell us? Just I know you probably did in your answers, but just boil it down to kind of what the overall theory is, and then what new things have been discovered or tested to enhance the probability and prove your theory.
Right. Well, it's basically that consciousness is not an emergent property of complexity. I think complexity is a big red herring, and I think it's often used as a kind of a to hide the fact that somebody doesn't know something. Well, it's complexity. You get complicated enough, and something happens. I think that's bullshit, actually. And I mean, emergence and complexity are important. I'm not saying that, but I think to explain consciousness and forget about everything else is not useful, and it doesn't lead anywhere. But some of my best friends are emergence and complexity theorists, and we disagree. But so I think it's pinned or tied to space-time geometry. So it's a function at the most basic level of the universe that is in this hierarchical system. For example, every three orders of magnitude, things repeat, and that may happen in space-time in the universe itself. And this leads. So you asked what's been new in this, and I'd say two things. Number one, we've shown in a series of experiments by Honorbahn and some other people that mostly Honorbahn, that there are these coherent quantum oscillations in microtubules. Then we've done experiments showing these quantum effects in microtubules are inhibited by anesthesia
Hmm.
selectively, and then the also pharmacological experiments. For example, a guy named Michael Wiest at Wellesley. In a This is a very clever experiment because he did it with a small college, a few students, about a dozen rats. He put the rats to sleep with isoflurane, but half of them he gave a drug called epopholone B, which stabilizes microtubules. And they get the epopholone B and they still move around like normal. but the drug is bound to the microtubules, and those rats required more anesthesia to go to sleep. So it's showing that that anesthesia must be acting on the microtubules, and other
Right.
experiments like that. And then Arat Kalra at Princeton's lab of Greg Scholl did an experiment on uh, uh, fluorescence, tryptophan fluorescence lifetimes. If you hit a protein like a microtubule with UV light, after a short period of time, it emits a photon at a lower energy. This is fluorescence. This is very well known. And the duration before the emission and the distance to which it propagates through the microtubule so that it's emitted further down is inhibited by anesthesia. So it shows that anesthesia is acting on quantum optical effects in microtubules. So these experiments, Honor Bonds and the others, and also some work by Travis Craddock modeling microtubules and showing terahertz oscillations inhibited by anesthesia, uh, all point to microtubules as the site of anesthetic action and consciousness. But I think an overarching thing is a fairly new discovery of honor bonds again, called time crystals, and this is pretty strange actually. So a crystal, a spatial physical crystal like salt or quartz, is because
Mhm.
the atoms line up periodically in a lattice, and so it's the same everywhere. A time crystal, uh, in a time crystal, dynamics repeat at different frequencies. So you can have the same pattern, like in the case of a microtubule, a triplet of triplets. You have three peaks, and each peak has three peaks at kilohertz, megahertz, gigahertz, and terahertz, and probably faster and smaller. And there's some evidence this happens in space-time geometry itself, and that other biological molecules have it too. So it seems to be something intrinsic to the universe. And this is something we're looking into now. There's a physicist group led by Nassim Haramein, who's also controversial but brilliant, and he's finding evidence that the triplets of triplets are in the universe. So these time crystals are, I think, maybe turn out to be the key to life and consciousness in biology.
Hmm.
And I think microtubules are time crystals. And time crystals were first proposed in biology by Art Winfrey at University of Arizona in the 60s. And then in 2012, Frank Wilczek, who won a Nobel Prize for, I think, the strong nuclear force or something, came up with the idea of time crystals in physics. And the problem is that it requires the ground state, the lowest energy state, to be a natural oscillator. And so that kind of sounds like a perpetual motion machine, which are not allowed in physics supposedly, but nonetheless can occur. And particularly if they tap into the energy of the universe, the 0 point energy, or in biology maybe KT or something. So I think time crystals are going to explain a lot, and uh, we're looking for those, and we're trying to document that.
So what does that mean for the future? I mean, I guess I think you kind of alluded to the fact you're not certain that consciousness can be created outside of the brain in a in a computer,
In a classical computer, maybe
in a classical computer.
future quantum organic room temperature computers, maybe. But uh, that's probably ways off. But people are working.
So AI technology will never become self-aware.
AI technology is as presently constituted. I would say no. And a lot of people disagree with me. And my friend David Chalmers, who I've known for a long time, who coined the hard problem, in the last few years has kind of thrown the hard problem under the bus, because he said, all these LLMs, they're so wonderful that it's inevitable that AI will be conscious. And I have to completely disagree with that. And for example, he makes the mistake of saying, well, what's the difference between silicon and carbon? And I go, Dave, wait a second. First of all, it's not carbon, it's organic carbon that we need. Uh,
Mhm.
in other words, aromatic rings which have quantum effects. So you need organic carbon, organic chemistry, which is the basis for life. I remember when I was an undergrad and I wanted to go to medical school, everybody said, well, if you want to get in med school, you got to ace organic chemistry. And I took that to heart and I did, and I studied hard and I did. And that's where you learn about these quantum oscillations and quantum interactions among the aromatic,
Yeah.
the pi resonance and all that. And so it's organic carbon, not carbon, and silicon doesn't have that. Silicon doesn't have the pi resonance or the possibility for that. So and organic carbon is and aromatic carbon is throughout the universe and probably has a lot to do with the origin of life and consciousness.
Does everything that is biological on the planet Earth have consciousness? I know I do, animals do. Do trees have consciousness? Do flowers have consciousness because they have organic matter and they have all these things going on? You talked about photosynthesis being a test factor, and they discovered that they had these collapses inside photosynthesis, which kind of leads to proving your theory. So, does everything that's biological and living have consciousness?
I actually think yes, and in fact,
Mm.
I'd take it one step further that I think consciousness was there before life started, and
Wow.
is probably
Wow.
why life started. I mean, Penrose objective reduction, which is again the only plausible or the only scientifically based theory of consciousness, other than hand waving emergence. I don't have to wave my hands when I say that. I just kind of like to do it, but would have been there at the time. So I thought about this and I asked Roger about it, but he didn't want to go there. He's got so many other things like the origin of the universe and this and that to worry about. But
Yeah.
it occurred to me that objective reduction would have been present in the primordial soup, and I've never been
Mm.
satisfied with evolution per se because life started and then genes didn't come along for I don't know millions or billions of years, and so how did we get from life evolving without genes. And evolutionary people say, well, yeah, you don't need genes for evolution. All you need is reproduction. And anyway, I'll come back to that point. But so anyway, I thought, well, maybe Roger's objective reduction was there in the primordial soup. It would have been everywhere. And these simple molecular complexes could have accessed it and had moments of consciousness or proto-conscious experience. So Roger says that if the collapses, objective reductions occur in a random microenvironment, in something that's not organized, then the moments of consciousness wouldn't be like ours. They'd be kind of random and disconnected. They'd be kind of here, there, and everywhere, and yet and not connected, no memory. So they come and go, and nobody would ever know the difference. Now, so it's kind of like proto-conscious noise everywhere. And this seems kind of bizarre, but, neuroscientists, when they can't explain consciousness, like Christoph, resort to panpsychism, where everything is conscious. Well, I don't think I think, attaching consciousness to as a property of matter doesn't work. But uh,
Like a rock is not conscious.
a rock as a whole is not conscious, but the
Right.
atoms within it could be having proto-conscious moments, but they're not talking
Mm.
to each other. So the rock as a whole is
Right.
conscious. But within it are all these proto-conscious entities, noise, not only in the rock and everything. And so to me, it's like to use a metaphor, if you go to the symphony and before they start to play, the musicians are tuning their instruments and they're tuning it to A and they have a method. But to me, a non-musical person, really, although I love music, it sounds like a cacophony. It sounds like noise. So,
Mhm. Mhm.
that's like proto-conscious noise, and then the orchestra starts, and you get a symphony, and so I think, what the brain does, and specifically what microtubules do, is to orchestrate the proto-conscious noise, like the instruments being tuned up, into Brahms or Beethoven or the Beatles or whatever,
Yeah.
and I think.
That's a great analogy. That's a great analogy.
Thank you. In fact, I think, consciousness is more like, music than computation because,
Yeah.
the music itself has the consciousness built in. You don't need a listener. And so, that's a yeah, I like the metaphor for sure. Thanks. Anyway, the proto-conscious so going back to the primordial soup for a second, so, the molecules, which are these same aromatic rings that were present there,
Mhm.
would have had started having these protoconscious moments, but occasionally some of them would have been pleasurable. And if that were the case, then they could be a feedback fitness mode for the system to optimize pleasure. So they would self-organize and grow and develop, all aimed at optimizing pleasure, because every function kind of needs something to optimize, and that's how life started and has developed. And so I wrote this paper in 2017, and a colleague of mine, now a colleague, Dante Loretta, who is a planetary scientist at the University of Arizona, who was in charge of a NASA project that sent a probe to an asteroid called Bennu to bring back organic material from the early solar system to study. And he promised that it would help reveal the origin of life. And so once the mission was successful and they were on their way back, well, it wasn't successful until it actually landed. He thought about, well, how was he going to prove this? And he had the idea himself that maybe consciousness was there. And he went to the literature to find papers about it, and the only one he could find was the one I wrote. And he said, "Well, who's this crazy guy?" And turned out I was across the street at the same university. And so he
Wow.
emailed me, and this is a few years ago. This is, I think, during COVID. And to make a long story short, when I retired from anesthesia, I went to work under him in astrobiology, and we're looking for the origin of life. And
Wow.
uh,
Wow.
stay tuned to
That's
that. I think it's
fantastic.
gonna be pretty cool.
Before we wrap up, we always ask all of our guests, what do you think about? What kind of maybe keeps you up at night, or what do you just constantly, hmm? I'm really curious about that. What is that one thing?
It's been consciousness for a long time. Microtubules
Okay.
and, other things too. I mean, I have other interests, but, it is kind of my obsession, I have to admit, and, it's really the most interesting thing there is. I have other interests, for example, applications of it. For example, uh, Alzheimer's disease has always been an interest of mine, because, in Alzheimer's disease, there are two types of lesions. There are the amyloid plaques that are outside the neurons that all the drug companies attack with these anti-amyloid antibodies and so forth, which
Hmm.
don't work. They're very expensive. They're toxic. They don't work. The other lesion is inside the neurons when the microtubules fall apart and a protein called tau, which is a microtubule associated protein, falls off and forms these neurofibrillary tangles. The microtubules destabilize and they disassemble, and so the neuron shrinks. You lose synapses. The whole brain shrinks. The brain atrophies and you lose memory and cognition, and that's Alzheimer's. And everybody's been attacking
Wow.
the amyloid
Wow.
plaques without any success. So you know, I, I wondered if there's a way to promote the microtubules to reassemble, to repolymerize. And so this was back in when was it? This was about over 10 years ago, about 12 years ago, after Audubon's papers came out. So I said, okay, so they have kilohertz, megahertz, gigahertz, terahertz. How can we interact with that? And kilohertz is electricity. I wasn't interested. Megahertz is radio waves. I wasn't interested in that. Gigahertz is microwaves. I wasn't interested in putting microwaves into anybody's brain. Terahertz is photons, and pretty harmless, but hard to get in. But then I looked across. I was an anesthesiologist, as we mentioned, and I looked across the room, and there's an ultrasound machine which we use for scanning, for imaging inside. Ultrasound,
Yeah. Yeah.
you can see the fetus in the womb. You can look
Yep.
inside, and we use them in anesthesia to find the jugular vein for lines or nerves for nerve blocks and this and that. And it's megahertz, but it's megahertz mechanical vibrations. So to make a long story short, I went to the literature to see if anybody put it into the brain. It had been done in animals, but it was approved for imaging in humans. And I told my colleagues in anesthesia, and we had a chronic pain clinic where with patients who are often depressed, usually depressed. I said, "We should try it in our chronic pain patients and see if they get better." And they said, "Yeah, right, Hammer." That was my name in anesthesia. "You go first," as if I put him to sleep with a hammer. That was kind of the joke, but
Yeah.
I used propofol actually, but to put him to sleep. So they said, "Okay, you go first. You got a nice shaved head. Your idea. Go ahead. We'll watch." And so, the end of a long day in the OR, we sat around a table and we wheeled in a machine, and I put this goop on and the gel, which is the worst part about it, and turn the machine on, put it to my head, and held it there for about 15 seconds, not knowing what to expect really. and I didn't feel a thing, and I was disappointed. And I put the probe down. I said, "Well, that's too bad." But then about a minute later, I started to feel kind of buzzed. I was kind of energized for
Wow.
about an hour or
Wow.
two. And so I said, we should try this on our pain patients. And we got approval, and we did the study in a double-blind control way, and we showed an improvement, significant improvement in mood and an improvement in pain, and published in the journal Brain Stimulation that would turn out to be the first study of ultrasound on human mental states. And since then, it's really taken off. Now, most people use it on focus ultrasound to target a particular area. We used unfocused, and I tried to get my peers at the University of Arizona to study in Alzheimer's, but they weren't interested. We did a pilot study and saw anecdotal results, and other people have started doing it. And for example, recently there's been a lot of studies on clinical studies showing that ultrasound not only improves the memory and cognition, but actually reverses this cortical atrophy, and the brain actually gets bigger again. After shrinking, it gets bigger again.
Mm.
And the only conceivable way that I can see that happen is that you're stimulating the microtubules to regrow and repolymerize to make neurons.
Wow.
You don't necessarily need neurons. The same damaged neurons can grow and make new synapses, and you regain cortical bulk, and the brain can regrow itself. So, and we're trying
That
to.
would be fantastic. That would be a fascinating, a life-saving breakthrough for so many people. And I say that, and I'm encouraging you to do it only because my mother passed away with a complication from Alzheimer's,
Yeah,
and to see her decline, it's heartbreaking. It's heart-wrenching, and no human being should suffer that because it's so just, it's not what we were born to do, to live a life like that.
I agree completely. And going after it with these expensive toxic drugs that don't work. And I was asked, why are they keep? I don't know. I don't want to attribute profit motive or anything, but the ultrasound approach would be very inexpensive. You can get a handheld ultrasound device for $150. They could treat 100
Wow.
patients in a couple hours. And that's kind of my dream. On my bucket list is there's a memory care center about a mile from here, and I want to, with permission and approval and everything, just go from room to room and give everybody some ultrasound and see if they get better. And the review studies have shown basically no harm, safe, mood enhancing. It's painless, it's safe, it's non-invasive, and that's what we should be doing, in my opinion. And we're going to try and do it. I'm working with IONS, a group in California, Institute of Noetic Sciences, and California Institute of Human Sciences, and so we hope to be doing a pilot study on that pretty soon.
Well, Dr. Ameroff, congratulations. I hope that works out for you, man. And if that gets traction, we'll have you back on the podcast to talk about that because that's a whole different discussion. And it's absolutely fascinating. It's been a real joy talking with you and learning about this because it's such a deep, complex issue, and you've made it very digestible for me. And believe me, if I can understand it, a lot of people can
Well, you ask
understand
good
it.
questions. That's the key.
Well, thank you. Thank you very much. Thank you for being on Ignition Sequence. And I understand you're taking off for a basketball game. Go Arizona.
Thanks. Bear down. That's what we say there. So thanks a lot. Thanks for having me on. I enjoyed it very much.